Welcome to the Explainer. Today, we're diving into something absolutely crucial for programming, how we take everyday human decision-making and translate it into the exact syntax of C++ control structures. You know, if you've ever wondered how a computer actually makes choices and processes complex conditions, well, you're in the perfect place.
Here's our roadmap for today. We're going to map everyday decisions to code, check out relational operators, tackle the if-else structure, dive into some advanced logical operators, and then wrap it all up by building a real-world discount calculator.
All right, Section 1, Everyday Decisions to Code. Think about it. In our daily lives, we make conditional choices effortlessly, right? Like picking up milk if the store is open, or drafting an athlete if they're over 6 feet tall. Well, C++ needs that exact same decision-making power.
And to give our code that power, C++ uses the if statement. This is, hands down, our primary tool for decision-making. It basically executes a block of statements only if a specific condition evaluates to true. It's literally just like a university deciding to admit a student only if they hit that required entry test percentage.
So, let's look at the actual syntax. The compiler is pretty strict here. Your condition, it absolutely has to be in parentheses. And your executable statements are grouped inside curly braces. Oh, and don't forget, every single statement inside ends with a semicolon. Now, while the compiler itself doesn't really care about spaces, indenting makes your code incredibly readable. It lets you know exactly where a decision block starts and ends. Trust me, it's a lifesaver.
Moving on to Section 2, Relational Operators and Testing Conditions. We know how to write an if block now, but how do we actually mathematically test those conditions?
Well, we use our mathematical toolkit, relational operators. You'll definitely recognize the basics from algebra, but pay super close attention to operators that use two symbols, like greater than or equal to. In C++, there's no space between them, none. The compiler treats them as one continuous symbol.
Okay, watch out for this classic beginner trap. It gets almost everyone. A single equal sign assigns a value, but a double equal sign compares values. If you accidentally use a single equals inside your if condition, the compiler isn't going to warn you. Nope. It'll just evaluate entirely differently, creating this massive logical error that is, honestly, incredibly frustrating to track down. Let's see this in action. We'll break down a sample program comparing the ages of two students, Amar and Amara. Step 1 is initializing our integer variables to 0, which is just a fantastic programming practice. Step 2, we prompt the user to input the ages. And then Step 3, we test the condition using our if statement and a greater than operator. Actually, before even writing this out, a really great programmer will map it all out with a flowchart. It helps visually trace the sequence of instructions so you can avoid those pesky logical errors.
But here's a pivotal question to ask yourself. What happens if that condition just isn't true? Like, what if Amara is younger? Well, with a standalone if statement, our program simply does nothing. It skips the block entirely. So clearly, we need a more robust structure to handle those alternative scenarios.
Which brings us to Section 3, the if-else structure and handling alternatives. This is exactly how we elegantly program those otherwise scenarios.
Look at how much this expands our capability. The else block gives us a dedicated place to execute statements when the initial if condition turns out false. But remember, the else part catches literally all other cases. So if we're checking if Amara is older than Amara, the else block executes when he's younger, sure, but also when they're the exact same age. That means we really have to construct our logic carefully so we don't leave any gaps or accidentally mislabel a condition.
All right, Section 4, Advanced Logical Operators for Complex Conditions. Because sometimes software requires way more than a simple comparison. Like, say you're requiring a job applicant to have a BCS or a BSc degree.
Meet the AND logical operator. It's represented by two ampersands. This little guy strictly forces both conditions to be true for the final expression to evaluate as true. So if you need a basketball player who is both over 18 and taller than 6 feet, this is absolutely the operator you're going to use.
Now contrast that strictness with the OR operator, which uses two vertical pipes. Here, your expression succeeds if at least one condition is true. So if a candidate has that BCS degree or the BSc degree, boom, the statement is true. It's only when both individual checks fail that the whole expression fails.
And there's a really brilliant built-in efficiency trick here called short-circuit evaluation. See, your computer reads from left to right. If it's checking an AND expression and the very first condition is false, well, it already knows the whole thing fails.
so it stops evaluating instantly. That saves processing power. Oh, and it is absolutely vital to remember that AND has a higher precedence than OR when you start combining multiple checks.
Finally, we've got the unary NOT operator. It's just an exclamation point. You place it right before a condition to reverse its entire meaning. True becomes false, false becomes true. It's just an incredibly useful, quick way to flip your logic whenever you need to.
Okay, Section 5, Building the Discount Calculator. We've got all our building blocks now, so let's use them to solve a real, everyday business problem.
So here's the scenario. A shopkeeper wants to give a standard 10% discount on all bills. But if the bill is greater than $5,000, that discount jumps up to 15%. To calculate the final payable amount, we're definitely going to need our if-else structure. And since we're dealing with percentages and money, we need to declare our variables as double data types. That way, C++ can properly handle all those decimal calculations.
But wait, before you write the math, you have to beware of the integer division trap. Think about it. To calculate 15%, you divide 15 by 100. But if you divide an integer by an integer in C++, it just completely truncates the decimal. So 15 divided by 100 simply becomes 0, and 0 means no discount at all. You always have to write at least one number as a decimal, like 15.0, to actually get that correct 0.15 multiplier.
All right, before we wrap up today, let's rapid fire through some essential coding tips straight from our source material to ensure your code stays clean and logical. First, always put braces in your if-else structures. Honestly, just type the beginning and ending braces first so you don't accidentally forget the closing one. Next, indent your body statements for readability. Also, be very careful when combining those logical operators we talked about. And finally, use the complete if-else structure instead of just stringing together a messy bunch of separate single if statements.
And just like that, we've reached the end of our explainer. The absolutely crucial point here is that you now understand how to truly control the flow of logic in C++. I mean, these exact structures are the literal foundation behind the most complex software decisions operating in the world right now. So now that you've got this power at your fingertips, what real-world problems will you teach your computer to solve?